This is the 8th design iteration of this model, and it's starting to produce some decent downforce for a still lightly modified configuration. Last time, the large separation over the front's leading edge was addressed. It is not a great solution, it's pretty ugly, but it did take the front lift coefficient from a SCZ of negative 0.16 to negative 0.239. The aim here is to extend this improvement, which will allow a large rear wing, or the largest wing I have used before. The idea is that I want to open up the wheel wells, or lower the already lower than ambient pressure that they have. Using basic bluff wheels wasn't a consideration when I started running this model. It turns out they have a significant impact that we can now measure. Having never tested this function on any model, also never having read about it, I would have guessed they affected drag, that is, lessening it. Turns out, at the front, it's all downforce, and at the rear, it's all lift. Drag doesn't change. It adds 30% more downforce to the front, now at an SCZ of negative 0.309. The rear, it seems to be sealing the floor, so it's a reduction in downforce of 14%. This could be avoided by running some 80s space age hubcaps. Overall, there's a gain of 8% in downforce, with the aero balance now 60-40 to the front. There is a lot of room to add rear downforce. A bigger, wider wing is an idea, but there are other ways. This wing is another way, using the whole body as an aerodynamic device. Alone, this wing has a lift coefficient SCZ of negative 0.342, or thereabouts, depending on some interactions that we'll see later. It's a remarkably draggy solution, but it more than doubles the total downforce to an SCZ of negative 1.091. The lift to drag ratio goes from negative 0.75 to negative 1.17. With the rear wing alone contributing about a third of the total downforce, the balance is going to shift. Now 35-65 front to rear, which includes an increase of 25% for the front. Beyond the terrible drag that is inherent to this model, the total downforce is getting close to where I would be happy for a car with modest aero running a 70mm splitter height and 100mm for the rest of the floor. There is, however, a significant amount of development left. Getting more downforce from the front is always desirable for production cars. Modification to this model up till now, where I intended to avoid concepts that would require cutting to the body. For example, the rear diffuser is minute because the car's body is really low, maybe the lowest I have seen. The wheel well treatment before was orientated around the wheel arches that are typically seen on this car. It seems that the best solution for this particular model was to place a flap over a high gap, stopping the air accelerating off the bonnet and around the side. What is really needed is to take advantage of the very low air pressure behind the footprint of the tyre. There are two options. First is to extend the splitter's diffuser into this region like Formula One cars did in the early 90s. Then the other, not mutually exclusive, is to shape the bodywork to diffuse the air out of the wheel well around this region. Cutting out this section of the body is a far easier modelling option, adding 4% front downforce. Placing deflectors in this region is very common. The flow around here is complex. I've never wrapped my head around their function beyond lowering the pressure in the wheel well. Running them gives another 3%. Going with the first guess principles of having a go and getting positive results, I really need to know why. There are vector glyphs on the initial animated model that show airflow going every which way. Running a series of slices through the air outside of the model, we can see the rotation through the vorticity map and lateral vector glyphs. Just after the wheel, as the body starts again, there is less inwash that would be expected, or at least previously observed. When the air is pulled in behind the tyre, when the footprint separates from the ground, any asymmetry wouldn't be pressure driven due to the wheel well being at a lower pressure than ambient. If it was pressure driven, there would be inwash. Then, with the wheel well pressure needing to be as low as possible to enable better splitter function, inwash would run contrary to diffusing the splitter. The splitter tunnels incorporated into this splitter have been functionally useless since they were added. There's no negative effect, so they were going to stay until they worked. They are supposed to diffuse into the wheel well volume, but the air pressure here is too high. So the fact that the air is now ducted more effectively out from here will compound, contributing to front downforce, rather than just coming for a ride. While focusing on the front, I was also adding bits to the chonky rear wing. This wing was designed for significant downforce. However, there are compromises, as it needs to be one piece for the rules, and it also needs to be easily fabricated. Basically, it can be made from one sheet. One specific issue is that the wing extending out from the sides near the roof pulls air from above where the mid-spoiler pulls high pressure. Not only lowering the high pressure, but there is also accelerating air off the side. Adding end plates made the wing section work a bit too well. These upper side end plates were a compromise between rigidity and aero. The underside will work well in yaw. Placing strakes on the side of the roof, along with the bottom side end plates, added 4% to both downforce and drag, while not changing the total rear lift. So there is missing downforce from the body, not as much as I remember. Total drag went up more, likely because of this missing downforce. I changed the leading edge of the wings profile that slightly reduced drag, but with no extra downforce. This change coincided with the wheel well profile that was added. There was a net loss in downforce, even though there was a gain in the front. It reinforces that there is a problem with the way the wing interacts with the body. Any positive improvements with the wing are negated by the body. So finally, we're going to improve the interaction between the body and rear wing, cleaning up the area around the rear of the wing. Again, the sloping hatch seems to cause a problem. Firstly, it is the usual problem of the free stream wrapping over the trailing edge, creating drag and probably lift. Then if the wing works well, it is pulling the slow-moving air from the wake onto the wing's underside. These two things are complementing each other, pulling air from the wake and replenishing it with a rotating mass. The air is doing a lot of work, but not in a positive way. Placing material across this volume makes everything better, apart from the wing is draggier from the induced drag, but there is less drag in total over the vehicle. There is a 7% increase in downforce, 22% from the rear wing. The floor generally works better, but we're back to the same issue as before, the lack of front downforce, with a 36-64 front to rear split. The central spoiler section is able to be trimmed with some rough calculations from an old model. It says it will get back some balance to about a 45-55 split.